Okay, so welcome back, and now we're going to do 3 more examples and of doing substitutions using in evaluating definite integrals. So let's do the first one. So again, the only difference is we got to make sure we change the limits of integration when we do our u substitution. So in this case here, notice that if I have x cubed and x squared. So I know the derivative of x cubed is going to give me x squared. So I'm going to make this inside here u. So u equals 1 plus 2x cubed, which means du is going to equal 6x dx. And of course I don't have a 6 out here, so I'm just going to divide both sides by 6. And there I have it. But I'm also going to change the limits of integration here. So when x is 0, u is 1. When x is 1, u is 3. So there's my new limits of integration. So now what I get is I'm going to get u to the 5th du, and of course I have the 1/6. So now, remember, as long as I change the limits of integration, then I know I'm going to get the correct answer as long as I do my integration correct, because remember, definite integrals give you a number, okay? So as long as everything is in terms of u, this integral will be the same as this one. So let's do it. So now this is going to be what? I'm going to get 6, right? U to the 6 divided by 6. So I'm going to end up getting 1 over 36 u to the 6th power evaluated from 1 to 3. And really, all I have to do is it's going to be 1 over 36 times what? 3 to the 6th minus 1 to the 6th. Okay? Well, what's that going to give me? Well, that's going to give me what? It's going to be 1/36 times, well, 3 to the 6th is the same as 9 to the 3rd, which is 729. So 729 minus, and then 1 to the 6th is just 1. And so this is going to give me 728 over 36. The top and the bottom are both divisible by 4, so that's going to give me 181. Hold on. So 2. Sorry. 182 over 9. And that's the answer. Now what about this one? Now I've got e to the exponent, right? So I got a natural exponential here. Notice that I've got x squared here in the exponent, and out here I've got x. So I'm going to make my u equal to the entire exponent. 4x squared plus 3. And then that means du is going to equal 8x dx. Now I don't have an 8 out here, so I'm just going to divide both sides by 8. And so now I get my substitution, which is going to be 1/8 e to the u du. Now, my limits of integration, when x is 0, u is 3. When x is 1, u is 7. So now all I have to do is evaluate this. So now the antiderivative of e to the u is e to the u. So I'm going to get 1/8 e to the u evaluated from 3 to 7. And so that's just going to give me what? 1/8 times e to the 7th minus e to the 3rd. And that's as far as I can go without a calculator. So that would be the exact answer. Again, if they wanted an approximate answer, let's say out to 3 decimal places, you could put this in your calculator easily and write it out. Okay, the last one is we have a trigonometric function. Now, in this case here, I don't, because of the nature of trigonometric functions like sine and cosine, the derivative of sine is cosine, the derivative of cosine is sine. I don't have a sine in here. So I can't do a u substitution the way it is. I have to have either cosine or sine or some product or ratio of the two. Okay? So I'm going to have to use an identity. So the identity I'm going to use is the double angle identity. Okay? Or half angle identity, depending on how you look at it. I don't remember, but the identity that you're going to use is the one that involves cosine. So now I'm not going to use the Pythagorean identity. That's not going to help. Okay, so I've got to use one of the other identities. So in this case, I'm going to use 1 minus cosine 2 theta over 2 d theta from 0 to pi over 2. Now, why did I use this one? Because it gives me a cosine. And I can integrate cosine all day long. So now, let's split this up. And the reason why I'm splitting it up is I'm going to use a u substitution with this one. I don't need a u substitution with the 1/2. So this is going to be 1/2 minus 1/2 cosine 2 theta d theta. And now I'm going to split it up into two integrals. So this will be the integral from 0 to pi over 2 of 1/2 d theta minus the integral from 0 to pi over 2 of 1/2 cosine 2 theta d theta. Now, on this one, I'm going to use a u substitution. So I'm going to let u equal 2 theta, and then du equals 2 d theta. And so if I divide both sides by 2, I get d theta, or actually, yeah, I get d theta is equal to 1/2 du. And if theta is 0, then u is 0. If theta is pi over 2, u is pi. So now, what's going to happen here is I'm going to get the integral from 0 to pi over 2 of 1/2 d theta minus, now my integral is going to be from 0 to pi, 1/4 cosine u du. Why? Because d theta is 1/2 du. I had a 1/2 already there, so 1/2 times 1/2 is 1/4. Okay, now let's integrate. Okay, so now I have, well, this is just going to give me 1/2 theta, evaluated from 0 to pi over 2. And so minus, and this is just going to give me what? 1/4 sine u from 0 to pi. Now here's the thing, I'm subtracting this whole thing. Okay, so this piece right here is just going to end up being pi over 4 minus, now what happens over here? Well, this is sine of pi is 0 and sine of 0 is 0, so this whole thing is just going to be 0. So it's going to be pi over 4 minus 0, which equals pi over 4. And so that's the answer, pi over 4. Have a great day.